Okay, so the next step in our algebra journey is really solving equations algebraically. And what we will see in these sorts of questions is often you'll know the answer. You'll look at it and go, oh, I already know what the answer is. But the focus here is on how can you solve it algebraically. Okay, so it's the proof that goes with the final answer that you get. Okay, now to solve a question such as this, okay, so it's clearly an equation, it's got an equal sign in it, so we've got these two expressions, 2x plus 4 is equal to 10. What we want to do is what we call the balance method, which means we do things to both sides of the equation in equal amounts. So the first thing we want to do here is we want to get rid of this plus 4. So what we do is we put a little arrow and we go, we're going to take away 4, okay? And that's going to leave us here with 6, okay? And then on this side, we're going to do the same thing. We're going to take away 4. So to take away 4, because it's a plus 4 here. If that was a negative 4, it'd be a plus 4 here. So that balances that out. Okay, so 2x plus 4, take away 4, leaves us with 2x. Okay, and at this point, I'm sure a lot of you are thinking, oh, I know 2x equals 6, I know the answer to that. But can you prove it algebraically? So this is where we want to do the same thing to both sides again. So this is 2 times x. So to get rid of a 2 times, we want to do divide. So we want to divide by 2, okay, and divide by 2. So just to show you how that would work, okay, so we're dividing by 2, okay, so it basically becomes 2x over 2, 2x divided by 2, and we're cancelling those 2's like that, and it leaves us with an x, okay? And then 6 divided by 2 leaves 3, x equals 3 is our final answer. Okay, let's have a look at a couple of other examples using that same theory of the balance method, okay? And these are really good because they really show clear working. Okay, so 5x equals 30. We want to get rid of the times 5, so we divide by 5. Okay, 5x divided by 5 leaves x. 30 divided by 5 leaves 6. Okay, and if we put the 6 back into our equation, 5 times 6 does equal 30. So we know that we can check it to make sure that it works. Okay, then we have okay, so now we have the pronumeral on the right-hand side of our expression. So here we want to get rid of the negative 21. So we want to add 21. And so on that side, we also want to add 21. So that leaves us with y here. Negative 21 plus 21 is 0. And 17 and 21 here will give us 38, positive 38. And if we think about, if we put 38 back into this equation, 38 take away 21 will leave us with 17. And then finally, okay, so we have our 10 equals q over 3, okay? So we want to get rid of this q, okay? So we want to do the same thing to both sides. So we want to not get rid of the q, we want to get rid of the 3. So to get rid of divide by 3, we want to multiply by 3, okay? And just to show you how that would work, q over 3 times by 3, which would be 3 over 1, and then you would be able to cancel those 3's like that, and that will leave you just with a q. Okay, and then times by 3 on this side, so 3 times 10 will give you 30. Okay, and if you substitute it back in, 30 back in here, 30 over 3 will give you an answer of 10. Okay, so of all of these questions, it's really this key element here where the arrow to the next line and what you're doing, okay, that's the justification for algebraic solving.